Okay, welcome to the first session in the GCSE column GCSE revision sessions for autumn 2023. And today's session, you're with me. My name's Mr. Black. I teach at Pengley School in Aberystwyth. And today we're going to start off with the theme of these sessions, which is going to be looking at year 10 chemistry units. The reason we're focusing on year 10 now, we've done lots and lots of year 11 sessions. So there's plenty of material for year 11, but there's nothing for year 10. And as you hopefully know, you do have examinations that go towards your GCSE marks at the end of year 10. So it's a really important year for you. So let's get into today's session. Well, before I do that, I'll just introduce the follow-up sessions. So you can see session 1, atomic structure and periodic table, which I'm doing today. And then we've got session 2 next week, elements, compounds and formulas and balancing equations, some really essential key skills there, which will then lead us into a session I'll be doing the subsequent week, which is on groups 1, 7 and group 0 chemistry. And then we're going to finish off with looking at calculations. Okay, so let's get into the next slide. So the next slide I put in good link here for you, very useful. This is the off the WJC, it's off their website, and you may not know of it. It's the guidance. So on this website here, you'll get information about what you should know exactly for your exam. Something that I refer to regularly, and I think you'll find it really useful when you come to revise as well. So that's for the double award, and then this link here is for anyone doing triple award because you've got slightly extra content. So better for you to follow that link. And so now we'll start our session 1 looking at atomic structure and periodic table. So this is the periodic table, and you'll see here I've told you perhaps it might be worthwhile pausing the video if you're watching it and get yourself your periodic table. Okay. If you don't have a periodic table, you can get these online. But I imagine if you ask your subject teacher for a copy of the periodic table, they'll provide you with one. And just to point out to you, please, when you go in the exam, remember you do have one of these on the back of the exam paper, as well as something called the ion sheet, which you'll probably maybe looking at in there next week. So definitely worth having this with you tonight, or during your session. Okay, so before we start then looking at the periodic table in any detail, just to point out to you, each of these obviously represents an element of the periodic table, and by an element we mean a specific type of atom. So that's where I thought we could start tonight. I keep saying tonight because it is this evening, where we could start our session. So we're going to look at the atom, and basic things, but important things. You should first of all know the basic structure of the atom. So hopefully you recognize the features here. So we have our nucleus, and you'll see that in our nucleus we have 2 types of particle, and hopefully you know what those particles are. There are protons and our neutrons. And then our third type of particle is called an electron. You'll see the electron on these circles, which we call shells. These are also known as energy levels, but you'll refer to them as shells. And we're going to look at how the electrons go into these shells on some subsequent slides. Now, looking at our nucleus, we can see there's protons and neutrons. And a good question for us to kind of, explore these particles is, well, which of these particles is the proton, which is the neutron, the red or the green? Okay, so there are some things that are going to help us be able to identify which is which, and that's knowing the kind of charges that these particles have. So here's a table. You've probably seen this in your lessons. It's very important that you know the charge, mass and position of the particles. We've already covered the positions, but we'll just run through the charges. So the way I teach my students about charge and particles is a little kind of rhyme. P for plus, N for none or neutral, electrons are -1. P for plus, N for none, electrons -1. And those charges are really important for you, not just in year 10, but also in year 11 chemistry as well. Okay, and then we've got the mass of the particles. And the protons and neutrons are said to have a mass of 1, and the electron is said to have 0 mass. Now, when we refer to mass, you usually have units of mass, but we can't work in grams here. I mean, these particles are just so small, and the mass is so small. So the mass actual unit is called an atomic mass unit, and it's actually set off the mass of 1 proton. So they've said a proton has a mass of 1, and therefore everything's weighed relative to the mass of the proton. I'm going to come back to the electron in terms of mass in a second. We'll just quickly run through the locations. We've already done this already, but useful to know. Okay, so going back to the mass of the electron, you'll see how I've included this term negligible. Now, if you're asked to quote the mass, you can go straight for 0, but be aware that they may use the term negligible in their questions, and it's worth knowing that, that refers to the mass of a proton. Sorry, electron. And with the mass here, negligible means it has a value, but it's very small. And it's nearly 2,000 for the mass of an actual proton. Okay, so we'll move on from there. And we're actually going to use these charges now, the proton and electron charges, to help us go back to our original question, which was which of these particles is a proton and which of these particles is a neutron. So how are we going to do that then? Well, let's just put our table back up, and a really important statement that you must know for the exam, because we see this question asked lots. Okay, and it says atoms do not have a charge. Why is this? Okay, well, the reason atoms don't have a charge is because, well, look at your charges. We have protons that have a positive charge, so technically we've got lots of positive charge here. But the atom doesn't have a positive charge because we also have negative charges. And as we know from earlier, this is our electrons. And the atom doesn't have a charge because in an atom, there must always be equal numbers of these protons and these electrons. And this is going to help us now to identify which is which. So we've got 1, 2, 3, 4, 5, 6 negative electrons. 6 negative electrons, and therefore if the atom's not going to have a charge, which you must know atoms don't have a charge, there must be 6 positive protons. And I believe that that is the green particle. So the red particle is our neutron and the green is our proton, I think. Let me do my maths. 1, 2, oh, my eyesight's bad. No, there's 5 neutrons, 5 greens, there's 6 reds. So the 6 must be the protons. Okay, great. There we go. So the next thing we're going to do then is we're going to look at the periodic table. So we can work out how many particles these atoms have. So these atoms all share that general structure of the protons and neutrons in the nucleus, electrons on the shells. What makes them different is how many of these particles they contain. And if you go to the periodic table that you have in the examination, you'll see at the bottom there's a key or a legend. Okay, so they've called it a key. And here it's telling us what the values next to each element refer to. As you can see here, we've got a mass number at the top of the element, and then we've got an atomic number at the bottom of the element with the symbol represented as an X. Okay, so we'll see that in a second again on a subsequent slide. So here we go. This is from the key of the bottom periodic table. So we're going to explore now what atomic number and atomic mass actually means. So atomic number, this refers to the number of protons in our nucleus. Now, if you were listening and paying attention from the previous slide, you should also know that therefore, if that's telling us the number of protons, it's also telling us the number of electrons. So the small value or the value at the bottom here will be your proton number and also the number of electrons. And then the atomic mass. Okay, well, I'll be in a second. So the atomic mass is based on how heavy your atom is. So if you may go back to your masses that we did earlier, we can see that the protons and neutrons have a mass of 1 and the electrons have a mass of 0, which is why our atomic mass refers to the sum of our protons and our neutrons. Okay, so don't worry about those two numbers. I'll come back to that in a second. So let's look at this element here. This is sodium. It's in a slightly different format to the way you'd have it. The 23 would normally be here. Okay, so this is our atomic number, 11. This is our atomic mass, or mass number, 23. So what does this tell us about sodium? Well, remember, atomic number is the number of protons, and therefore the number of electrons. So we know there's 11 protons, and there's 11 electrons. And then the mass number here, 23. Remember, this is our protons and neutrons added together. We know there's 11 protons. To make 23, there must be 12 neutrons. The quick way I tell my students about working at neutrons is just take them away from each other. It's a big take away small. So if you look at our sodium atom, those are our particles, 11 protons, 11 electrons, and then 23 take you 11, 12 neutrons. Okay, so let's have a look at the next one. Here's calcium. Okay, so first of all, we're going to look at the calcium in terms of how many particles it's got. So I'm just going to let you have a quick look at the symbol, and you can have a little reflection on how many protons, electrons, and neutrons there are. And those are your values. So we have 20 protons, we have 20 electrons, and we have 20 neutrons. Now, what I'm going to lead on to next, then, and hopefully you're happy with where these values are coming from, protons, electrons, take away neutrons. We're going to put our electrons into the shells. Remember, the protons and neutrons are going to go here, right in the middle, in an incredibly small structure, our nucleus, and we're going to put our electrons on the shells. Now, we've got 20 electrons here, and when you put electrons on shells, it's really quite simple. First of all, we work our way from the very first inner shell right next to the nucleus, and we work our way outwards. We don't move to an outer shell unless an inner shell is full of electrons. And the number of electrons that go in shells at GCSE is very simple. We just say the first shell holds a maximum of 2 electrons, and after this, all subsequent shells can hold 8 or up to 8 electrons. It's not quite true, but it works for GCSE. So let's take our 20 electrons. We're going to start putting them in the shells. So we can put 2 of those electrons in the first shell, and that shell is now full. No more room. So that allows us now to move on to our next shell, which can have another 8 electrons. Okay, so far I've put 10 electrons in. I've still got 10 to put in, but there's no room on these shells here. So now I'm allowed to move to my next shell. And again, as I said earlier, this can hold another 8 electrons, and then it's full. So now I have 18 electrons on my next shell. I've got 2 left over. And this shell here can hold those 2 electrons. Okay, so this is now referred to as my outer shell. This shell here hasn't got any electrons in, so is it an outer shell? If you wanted to call it anything, you could call it a vacant shell. Vacant means empty. So this is our outer shell, and we can see here in our outer shell we have 2 electrons. Now, just to point out, there is room for more electrons. We just don't have them. Remember, this shell could hold up to 8. Okay, so that's your calcium. So let's have a look at perhaps another atom now. Oh, and this is also another way you can talk about the electrons in shells. This is when you're asked to write the electronic structure, or sometimes they might use the word configuration. Maybe not, that's more A level. So GCSE electronic structure 2882, and this is just reflecting how many electrons are going on at each of our shells. 2, 8, 8, and then 2. Okay, so let's look at our next elements. This is sodium. So I'm going to give you a moment just to think about how many protons, electrons, and neutrons it has. And hopefully you've done this. Okay, so 11 protons, atomic number 11, therefore 11 electrons. And then to work out our neutrons, we're just taking these 2 numbers away. Okay, so that gives us our 12 neutrons. So now we're going to put the electrons on the shells. So let's go. So let's put our electrons on. So there's our numbers that we're going to work with. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, hopefully you've seen the deliberate mistake. I do make mistakes quite often, but this is a deliberate one. And the reason I've done this, I've seen my pupils do this quite often. especially with elements where the numbers aren't all equal. So for our calcium, it was all 20, 20, 20, so not a problem. Hopefully you can spot here that what this student's done, or what I see many students do, is they put the neutrons on the shells. Okay, there are 12 neutrons, but they're not on the shells, they're in the nucleus. Remember, it's the electrons that go in the shells. So we've got too many electrons here. This is wrong. Okay, so we need to make sure that we've got 11 electrons. So there's our sodium atom now. So when you're in the exam, please make sure that you don't do something as silly as put the neutrons on the shells. Make sure you put your electrons on. Okay, so let's do another example now. So here we've got magnesium. And you can see that magnesium has got, well, you can see it for yourself, how many protons, electrons, and neutrons it's got. So we can see there's 12 protons, and therefore there must be 12 electrons, and therefore there must be 24, 24 take away 12, so there must be 12 neutrons. Okay, so we've now got this idea of how to work out our number of protons, how to work out the number of electrons, and how to work out the number of neutrons. And if we were to put these electrons on the shells, remember we'd got 12 altogether, so we would have 2 on the first shell, 8 on the next shell, and 2 on our outer shell. And we'll come back to that in a second with our structures. Okay, so there's our protons, electrons, neutrons. Sorry, protons and electrons, and that's our going to help us work out a number of neutrons. Okay. So the next thing we'll look at is, it's intrinsically linked to atomic structure. And we'll explore this term isotopes. Okay, so what I've got here then, I've got, well, 3 atoms, and if you look at the atoms, they're not the same, they're slightly different. But to all intents and purposes, they are the same atom. And what I mean by they're the same atom is they've got the same number of protons. And really, it's the number of protons that defines an element. Any atom that has 1 proton is the same element of the same atom. And you might look at this and say, well, they've got different number of neutrons, so they can't be the same. Well, I refer to neutrons as bubble wrap. They're packaging. All right, they don't actually affect the chemistry. So in terms of the properties, the chemistry of this substance, these atoms are gonna be exactly the same. You would not be able to distinguish them. So yeah, these are what we call isotopes. Okay. And you really do need to know a definition for isotopes. Quite a common thing to be asked in the exam. So if you ask what an isotope is, you just, as I've said here, atoms with the same number of protons, different number of neutrons, and that is going to get you the mark. Okay, so the atomic number then, let's practice that skill. What's the atomic number of these isotopes? Well, they all have the atomic number of 1. Remember, atomic number is the number of protons. And that's a key thing about isotopes. The symbols of the isotopes will all have the same atomic number, as you're about to see, because I'm going to put those up for you. Okay. And then the atomic number, remember I said to you earlier, actually defines who you are. So what you would do then, if you just grab your periodic table for me, hope that's in front of you now, and see if you can find the element with the atomic number 1. And you should see that this is hydrogen. Okay. And so these 3 atoms are what we call the isotopes of hydrogen. Okay. And I'll just show you there the differences with the number of neutrons they contain. And we can see that from our atomic number and our mass number values. So the atomic number of 1, because it will have 1 proton, but the mass numbers are different because they've got different number of neutrons. So 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3. Okay, so moving us along now, let's look at some more examples of isotopes. Okay, wait a second. So just very quickly, what I'm going to ask you to do is, can you just identify which isotope these are atoms of, or what, sorry, not which isotope, which elements these are isotopes of? Okay, so we need to really think about the atomic number here, don't we? So let's get our periodic table up. So I've got one here as well, just in case you don't have one in front of you. So I'm going to make it a little bit larger. Okay. And we'll just pull our atoms up so we can see them again. So remember, which particle defines you? It's the number of protons. This is your 17 protons here and 17 protons here. So this makes them isotopes of the same element. Isotopes because they've got the same number of protons, but different number of neutrons. And which element are they isotopes of? Well, let's have a look at the number of protons. Okay, so we have 17 protons, and if you look at the periodic table, that means our atomic number is 17. So this looks like it's isotopes of chlorine, which it usually is. Okay, so there's our isotopes of chlorine, and there's the symbol. Now, what I want to notice here, those are the two. If I was to put atomic numbers, obviously both would have the atomic number 17. And if I was to put mass numbers, this isotope would have a mass number of 35, and this isotope would have a mass number of 37. So it's 17 plus 18 and 17 plus 20. If you look on lots of periodic tables, you'll see that, you know, chlorine doesn't actually have a whole number for its mass number. And this is because of the existence of isotopes. And any element you see in the periodic table where it's not a whole number, you'll recognize that that is something that does have isotopes. So good examples would be, another one is something like copper. So if you look in your periodic table, you should see it has a mass number of 35, 63.5. It's not in front of me, but 63.5. And that kind of tells me that as well, there's some isotopes there. Okay. So yeah, that's our isotopes hopefully covered. Just to reiterate to you that isotopes have the same number of protons and therefore same atomic numbers, but different numbers of neutrons and hence different atomic mass values or mass numbers. If you are doing triple award, one of the things that you'll be expected to be able to do is to see where this actual value comes from. There's a little calculation you can do. It's fairly simple, and I think that's something that we'll probably try and cover in session 4, where we do some of the calculations with the year 10 chemistry. So yeah, we're about halfway through the session now, which is a kind of a good place to be. Just want to make sure that you're happy with everything we have done so far. So hopefully now you recognize which is atomic number, which is atomic mass. You know how to use atomic number to work out your protons and your electrons. And you also know how to use atomic number to work out your neutrons by subtracting it from the atomic mass. Hopefully you know how the electrons go into our shells with our protons and neutrons in the nucleus. And yeah, that's pretty much where we got to. And then we've gone over the basic idea of isotopes. I'd say the most important thing about isotopes is learning that definition and being able to recognize when something is an isotope. Okay, so what we're going to go on to next? Well, I thought what we could do then is just have a look at the basic layout of the periodic table. So there's a couple of fairly basic things, you know, perhaps things you learned when you're in Key Stage 3. And the first one is this dividing line, or what people often refer to as our staircase. And I'm fairly confident you'll be sure with what the properties are, or sorry, what the significance of this staircase is. And it basically divides our metals from our non-metals. Okay, and what I've got here are the really, what I would say, the most important properties of a metal. I mean, metals have many important properties, but these are probably the most important ones that I would want to be talking about when I talk about the property of a metal. And what I thought I'd do then, if you look, the properties are pretty much opposite to each other. The one thing I'd say here as well, if you do have a non-metal that's a solid, it will be a dull solid. So they're not shiny solids, they're dull solids. When they are a solid, typically with their low melting and boiling points, these things tend to be either a liquid or a gas. So for example, you've got your fluorine, your neon, your chlorine or gases. Very few examples of non-metals that are liquids, but we've got bromine here, so that would be a good example. And we've got iodine as well, which is actually a solid. Sulfur as well is a solid. So, you know, there are some solids, but even so, the melting points are relatively low in comparison to metals. And just a little sorting exercise then, hopefully you'll be able to kind of put these into the right place, metallic or non-metallic. I won't go for that too far, but I do want to just very quickly talk to you about two terms here that I think are quite important for you. And it's this word malleable. So I want to understand the concept of something being malleable and point out the difference with something being flexible, because students quite often mix those two terms up. Malleable means the material can be bent into a new shape. So once you apply force, it will bend. And when you release that force, it will have that new shape. It won't go back to the original. Whereas flexible means that the material would be bent under a force, change shape. But when the force is released, it goes back to its original shape. The opposite of malleable is this term brittle, when it's a solid. So if you try and bend these materials, they're not very flexible, and before bending, they'll shatter. So, I mean, not that glass is an element, of course it isn't. It's a quite complex material, lots of elements in there. But I would describe glass as being brittle. So if I was to drop glass, it would shatter. If I tried to bend glass, it wouldn't bend, it would snap. So fairly simple. I mean, to be honest, that's kind of your GCSE Key Stage 3. But then we're going to bring in a new term, and it's this term here, metalloid. You may also see them referred to as being semi-metals. And I want you to notice their location, because that's quite important. You can see that they are straddling between the metallic elements and the non-metallic elements. So it's these ones are marked in red. You don't have to know specifically who is a metalloid, but you do need to know their general location. Okay. So what's a metalloid? Well, it's pretty obvious what a metalloid is. It's something that's like a metal, but not a metal. Okay. So we kind of say that they've got the properties of a metal, but they've also got the properties of non-metal. And what I always say to students when asking questions about this is, if they are talking about a metalloid and they're specifically looking at information about a material, when you're identifying that material as a metalloid, say what properties of it are metallic, and then say, but it's not metallic because it has this non-metallic property. And be very clear in stating what the metallic properties are that make it help you classify it as a metal, and then what property kind of makes you struggle to classify as a metal. And you can see here I've talked about things like carbon. Okay, so carbon is well, it's a semiconductor, so it can conduct electricity in some forms, but not very well. But it's dull. Oh, it's got a really high melting point, okay, as well. So, that makes it look like it might be a metal, but it's not a metal. It's a dull black solid. Yeah, so it's quite hard one, actually, that one. I'd say carbon's a non-metal myself. But if we look at silicon, here we go, here's silicon. Now, this is a metalloid, okay? And silicon's got that kind of classic properties of metal. If you look at the color here, it looks metallic in that it's shiny. And look at its melting point, boiling point. Those are typical melting points and boiling points of a metal. So yeah, I'm looking at this and thinking, yeah, this is a metal. However, it's brittle. So if you were to hit that with a hammer, it wouldn't dent like a metal. You wouldn't be able to shape it. This would just shatter. And I mean, it can conduct electricity. That's why it's in microprocessors, but it's a poor conductor of electricity. So that makes silicon a metalloid. It has properties of both a metal and a non-metal. And like I say, look at the information they give you and be specific and state this is metallic, this is non-metallic. Okay, so next one then. We're going to need our periodic tables. Okay, so don't worry about this. It's just lifted straight off somewhere, off one of my exercises I do at school. But you should have a periodic table in front of you, hopefully. And we're going to look at group and period now, because this is obviously another important part of our periodic table. So what is a group? Well, a group is a column in the periodic table, and they contain what we call families of elements. And really, really useful to know that if you've got elements in a group, and we'll see this when we look at groups 1 and 7, the chemistry is very, very similar, even to the extent that we can interchange symbols for elements in the same group within a balanced equation. And that makes life so much easier knowing that thing there. But yeah, so group is commonly the periodic table, and you'll see patterns in the groups. Like I say, the chemistry is very similar. You'll have differences in how reactive they are. So you might see that in some groups they become more reactive, in other groups they become less reactive, but fundamentally the chemistry is the same. And then you'll see trends in properties, physical properties. And what I mean by a trend is that a pattern establishes itself, like, for example, melting point and boiling point. But I'll be looking at that when we look at groups 1 and 7. Okay, but there you go. You can see, for example, if we looked at group 1 or column 1 of the periodic table, we will see reactivity increasing down that group. And then we'll see things like melting points and boiling points. There's a trend in that they decrease in the melting and boiling point. Okay. Oh, in their density increases. Okay, so group 7, which we'll look at later as well, it's actually the opposite. Group 7, by the way, these are the 7th column. We'll look at that because we'll have some periodic tables in the PowerPoint in a minute. And we see as we go down group 7, these elements do the opposite in terms of reactivity and also in terms of melting point and boiling point. So it's quite interesting that way. Okay, so there we go. So here's our periodic table, and you can see what the exam board have done for you is quite nice. They've actually labelled or numbered the columns for you, so you don't have to kind of count the columns across. You'll notice this block here in the middle hasn't actually got a group number on your periodic table. Okay, so GCSE, WJC, we say there are 8 groups. Okay, groups 1 to 7. And at the very end, we have this group, which we refer to as group 0. And we're going to talk about why it's called group 0 a bit later. Okay, so as I say, we have our groups. These are the columns that we see in the periodic table. And then we also have things called periods. Okay, now the periods are referring to the rows of the periodic table. Okay, so we've got groups and periods, which are like rows of the periodic table. And one of the things the exam board wants to be able to do is to identify the group and the period of an element. So what I'm going to ask you to do now, with your periodic table in front of you, could you just have a quick look and identify the group and the period of, let's say, magnesium. So go for the group and the period of magnesium. Right, so hopefully you identify magnesium as here. Okay, so it's in this location. So we can say it's in group 2. Okay, so it's in group 2. Now, really common mistake. I see this lesson after lesson. I keep pointing it out, but it's so easy to do, especially in the pressure of the exam. Try not to make the mistake. You may have thought it's in period 2. And the reason you think it's period 2 is because it's in row 2. 1, 2. So period 2. However, you can't forget this period at the top here. This is hydrogen and helium, and this actually makes up period 1. It would be nice if perhaps we had helium a bit more over this side so you could see it. But when you're doing your group and period, please don't forget your period 1. So as I say, it is group 2, but it's also period 1, 2, 3. Okay, let's do another element. Let's go for silicon. Okay, so I'll just show you where silicon is on here. This is silicon. So you can see almost immediately silicon is in group 4 and then period 3. And then let's go for another element. Let's go for, I don't know, let's go for this krypton. Okay, so which group is krypton in? Well, krypton's in group 0 and it's in period 1, 2, 3, 4. And then I'm going to finish off by asking you to identify the element in period 1. Sorry, not period 1, group 1, period 4. So get your periodic table, find the element in group 1, period 4. Okay, so group 1 is this column here. And I'm afraid if you went 1, 2, 3, 4 and identified it as rubidium, you were wrong because we've got to do the hydrogen helium period. So it's 1, 2, 3, 4. It was actually potassium. Okay, so a little exercise for you to try there on the next slide. Okay, so what I've got here is a little table of some group element. We don't know what the element is, but I've given it a group and period, so identify the element. And then I've got the element here, and you're going to identify the group and the period. So I'm just going to wait for 1 second so you can pause. You can fill that in yourself. And now, just to check your answers, let's see if you were right. Okay, so look at your periodic table. Let's see if your answers match what I've got. And hopefully I haven't made any silly mistakes. Hope I haven't got my hydrogen helium period, but I think they're pretty good. Okay, so where does that lead us on to? Well, group and period is quite an important concept for us, okay? Because what group and period allows us to do is to actually kind of get some idea about electronic structure of an atom without having to put all the electrons in the shells, or even indeed work out how many electrons there are. So let's see how we can do that then. So we're going now to look at group and period and how it actually relates to the position of an element in the periodic table. Okay, so if we just start here. First of all, what I'd like you to do is tell me how many protons this atom has. So before we even did anything with group and period, how many protons does this atom have? Well, hopefully you've remembered that atoms don't have a charge. And here we have 20 electrons, and you remember they have a negative charge. And therefore, in our nucleus, we'll have to have 20 protons. Okay, so looking at the periodic table, we know that this element has to be calcium, okay, because it's the only element with that atomic number of 20. Okay, remember, protons refers to atomic number. So 20 protons, that must be calcium. So we know already from our previous exercise that calcium is in group 2, period 4. But we're just now going to look at how we could have identified this as calcium from looking at how the electrons are arranged in the shells. Okay, so the most important thing for you to know is that the number of electrons on the outer shell of an atom refers to the group of the element. Okay, so if we look at this outer shell here, remember this outer shell doesn't have to be full, this inner shell doesn't have to be full. We can see there's 2 outer electrons. So what that tells me then is that calcium must be in group 2. Okay, and it is. Okay, so that's really, really important for us. The group directly relates to the number of outer electrons. So for example, if we went to an element like, I don't know, oxygen, we see it's in group 6. If we were to draw an oxygen atom, we would see that that oxygen atom has 6 outer electrons. And in fact, we can see that the atomic number of oxygen is 8, which means it's got 8 protons and 8 electrons. 2 of those go on the first shell, and what a surprise, 6 of them would go on the outer shell. But it doesn't just tell us group, the electronic structure. We can also establish which period this element belongs to. So period relates to the number of shells that the atom has. So if you look at this atom here, we can see that it has 1, 2, 3, 4 shells. So this is in group 2, as we've said, because of the 2 outer electrons, but we also now know it's in period 1, 2, 3, 4, period 4. So let's just double check. We'll hopefully see calcium there. Period 1, period 2, period 3, period 4. So what's the take home from this? Well, the take home from this is that the group is the number of outer electrons, and the period refers to the number of shells. Okay, let's have a look at another element then. Okay, so another element then, I've drawn it for you here. I've even marked on the symbol of this element. This is argon. Okay, again, you should be able to tell me how many protons this argon has. Okay, and you should be doing that by looking at how many electrons it has. Remember, protons, electrons in an atom have to be the same. I get bored of saying it myself. Atoms don't have a charge. So we've got 1, 2, as you'd expect. 8 on this shell, I'm not even going to count them. So that's 10. And this is an out shell, so I'm going to have to count here just to check, because this doesn't have to be full. 1, 2, 3, 4, 5, 6, 7, 8. So it's got 2 and 8 and 8. So first of all, we can see here that this would have 18 electrons and therefore 18 protons and atomic number of, there we go, 18. So yeah, argon, exactly as we'd expect. And we're going to look at its position now. So we'll start off with the period. So period, you tell me what the period is first of all. So I'll just get a little pause here for you. So you can see here, we have got 3 shells of electrons, 1, 2, 3. So this tells me argon is in period 3. Let's just check 1, 2, and 3. There's argon. Okay. And then our group. Okay, so group, it refers to the number of outer electrons. And if we look on this outer shell here, we've got 8 outer electrons. So this means then argon is actually a group 0 element. And what it is with group 0, this group here, they have a full outer shell. All right. So this is why argon is in this group. It's got a full outer shell. All these elements have full outer shells. If we go to the helium, you'll see here helium has got an atomic number of 2. So it's got 2 electrons, which means on the first shell, it has 2 electrons. And that makes that first shell full. So this is why helium's also in group 0 as well. Okay, so yeah, that's, I mean, covered pretty much everything. Now I'm just going to go back to another slide, if you bear me a second, so I can see. Where is it? Oh yeah, let's go to, let's look at this element here. This was our sodium, okay? So let's look at where sodium is in the periodic table. It's in group 1, and it's in period 3, okay? Let's see if we've got any more we could look at. I think we have. Well, yeah, we've got our chlorine. So if we go across to our chlorine, and you can see here, we've got one, or let's just double check here on the outer shell. We've got 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell. So there's our chlorine in group 7. Okay. And then if we check our period, 1, 2, 3. So if you look at your period table, you'll see that chlorine is indeed in period 3. Okay. So now we've got this understanding here of group and period. If we go back to this slide here, I can tell you about the structure of these atoms now. I can tell you that this atom here would have 2 electrons in the outer shell and 3 shells of electrons. So I could actually say, without actually doing anything, 2, 8, 2, and so on. If we did iodine, I know iodine is a very, very big atom to draw. And actually, at GCSE, you don't know enough to be able to draw the atom properly because you don't know enough about the shells. Things get a bit more difficult as we move outside the furthest shells. But what you do know is that if you were to draw iodine correctly, you would have 7 electrons on the outer shell, and you would have 5 shells of electrons. Don't practice that, by the way. There is a little bit of extra chemistry you need to know to be able to do iodine's electronic shells. Here we've got potassium. So potassium's 19 electrons, and I'd expect there, when you were to put those 19 electrons in the shells, 1 in the outer shell, and you would have 4 shells. And argon we discussed earlier, full outer shell. Anything in group 0 has a full outer shell. So in this case, 8 electrons, and it would have 3 shells. So yeah, I mean, I've covered what I really wanted to cover today, which was, you know, the basic structure of the atom, the nucleus with its protons, neutrons, electrons, using your atomic number and atomic mass to work out how many protons, electrons, and neutrons you have. You being able to put those electrons on the shells correctly, and then also identifying the group and period and knowing what those terms mean as well of an element based on this electronic structure. And also we did get to look at isotopes as well. So we've got this appreciation that there are these things called isotopes, and that, you know, essentially they're the atoms of the same element and same number of protons, just different number of neutrons. And that finishes today's session. So I hope you found that useful. You may need to play it back in parts and perhaps pause it and try and do some of the exercises as I go through them. Next week, I think we're going to be looking at elements, compounds, and formulas and balancing equations. Certainly, it will be most of those topics. The balancing equations, maybe we'll see. Hopefully, and yeah, as I say, hope you found it useful, and we will see you on the next session.